Welcome everyone to this new video. I am Jose Maria Lago, CEO of PurpleDye, and we are going to take a brief tour of the platform showing its main features. This is what we know as the dashboard. Here we have the different menus. We are going to review it, probably the top 3, which are the most interesting. The others are typical of any other platform. So they contain the account, the billing, the user profile, more typical menus. But we're going to review the top 3, which are the important ones. Here in the we have also notifications profile. So we check on the canvases. A canvas is a workspace that would correspond to Jupyter Notebook or a .py file in VS Code. Okay. So here we can see the different canvases, a list of them. So if we click on the detail of the canvas, we can see the members there are, the folders where it's located, or the tags, who has access to the canvas, etc. Tags work as folders, so here we can filter. It is also used by other platforms, but it's an interesting feature. Okay, so now we can go to Marketplace. Here we have all the data processing units or buttons, what we define as buttons. Okay, and mainly those are the building blocks that we are going to drag to the canvas. Okay, by now we only support working with structured data types, so we are not supporting image or video and so. And by now we have divided the buttons in input-output buttons, operations, models, and plots. Okay. During the beta phase of the platform, only PurpleDye workers can upload content to the marketplace, so nobody else have access to upload the content in that way. But the users can upload their private buttons from the My Buttons tab. We will review that tab later on this video. Returning to canvases, now we're going to see how we can create a new canvas, new workspace. So we click on new canvas, then appears this screen. Here we can write the name of the canvas. Here a small description, whatever you want. And here in the tags, which as we have mentioned, those are folders. You can include maybe 2 tags, playground and test. So here we click on next. And we can see this screen, which is used to invite our users. So here we can write an email with which they have registered on the platform to invite them. And remember that the canvas is a collaborative workspace that works in streaming. Here we're going to invite Xavi to this canvas. We set the role to admin. And if we go to the next screen, we can see a drop-down menu where we can select the machine that we are going to use for work. We can see the different instances with different resources, but I'm going to choose the smallest because for this canvas we do not need more. And if we had a large dataset, we would choose a bigger machine. Here we can see the average price, which refers to 8 hours a day, 5 days a week, and the maximum price is 20 hours a day, 7 days a week. If we click on Create Canvas, we see that it has been added here. Let's check on the details to see that everything is fine. Now we can see. And now we can open the canvas to see how it looks like. Let's now go back because this canvas was only to see the process of creating a new canvas. Now we enter this canvas that is already prepared so that the video is not so long. Here we can see an assembled AI pipeline. We start from a CSV with, the problem that we have is second-hand car data with features such as the car model, the year, type of fuel, mileage, etc. And thus we have to, in general we have to predict the price. So it's a regression problem. And with this button, here we have to upload the data in CSV format. Oh, let me check the machine state since the notification comes out. Here we can see with which machine we are working and in what state it is, and if it's executing something, or it's opening, or it's ready, because everything of this runs on the cloud. So through this button we upload the data to the platform right now. Then with the blue buttons we can do the ETL or data cleaning, so formatting the data, ordering the data, and basic operations. But we also have a plot so that you can see a plot type button. It's not that useful in this particular case, but just for you to see. And here we also have a model button, which is a random forest. If we open this button, here we can see the configuration screen with these parameters subscreen and the mapper with the different data tensors. It's very simple in the upload CSV. And if we click in a tensor, we can preview the data, load the data. And as we said, we can see all the previously set features such as the model, the year, transmission, mileage, fuel type, and those characteristics. And also we have here a download results button where we can always download the data from any tensor. Here we have an icon to report bugs and give feedback. This opens a Google Forms survey in a different tab, so you can explain all that. And here we can also see all the different actions that we can execute within the canvas. Now we're going to add a different button, a model, which will be a linear regression. And we're going to configure it so that you can see how it works. We go to the marketplace and we filter by models, and then we go to the linear regression and click on the no more, and then the model card will open. So the elements that we can find in the model card are who uploaded the button, a short description with many links to the documentation of the code, the input parameters with their descriptions, the different badges, and the input and output data types, which right now are only tower data. Similar buttons and buttons uploaded by the same user. Here's a concept that will be required to explain the different sites. And next we can see a use case, an example with different input tensors that we have to input to the model in this particular case, and we can see what the model has returned. Okay, we can also see the R2 score and the coefficients of the linear regression. And after that, going to the insights, we can see permutation importance plot and also different partial dependence plots, one per feature. Then some observations with the sharp number plot and the plots that aggregate those sharp numbers and show the distributions. Remember that the model card is fully configurable by the developer who loads it to PurpleDye. For now, there are no two ways to load buttons, there is only one. So PurpleDye workers upload buttons to a marketplace in the same way that users upload their private buttons. So now we close the model card and we drag the model to the canvas. Then we connect the same edges that the random forest has. So from the select KBS we get the X train X val, and from select columns we get the Y train Y val. We enter in the configuration and we see all the different parameters in the mapper. We are going to start with parameters. We want to see all the insights, so we set everything to true. And the rest of the parameters are very simple because these are linear regressions, so we don't change anything. And now we're going to connect the mapper. So the first tensor corresponds to X train, second to X val, the third to Y train, and the fourth to Y val. We also connect the X val to the transform channel so we can see the predictions. Then we apply all the changes we have made and we close the button configuration. Now we are going to execute the canvas, so in run mode. So we go anywhere and we right click and run all. Here it asks us to select another machine if we want, because maybe we need more RAM, memory, or computing power or storage. But this is because the machine that we have previously selected is to work with, and it does not use the entire dataset, it only uses a subsample. But when we are in the run mode, the canvas is going to be executed with the all dataset, the full dataset. So in this case, we're going to use the same machine that we are working with. And we click continue, now we can see how the canvas is being executed. We can see a tick, that tick appears if everything has gone well, a clock if it's waiting, the button, or a wheel if it's being executed. To see more details of what's happening, we open the terminal, where we can see the logs of what's going on. There are like many nodes for which we have not changed any parameter, so it is using pre-computed results. So it doesn't need to do any reckoning whatsoever. Now we see that it has finished, and it seems that everything has been executed correctly because we can see the ticks. So if we open the linear regression, we can see all the insights. Here we have a little problem with data formatting the tables, but we're fixing it. And we can see all the insights for this particular use case, for this particular data set. So now that we have the AI pipeline finished, we're going to proceed to assemble a REST API for this canvas, so all the envelopes thing. So we click on the rocket to start the deployment phase, and the menu opens. Now we can choose again the server machine that is going to be deployed with a number of copies. And now we add the REST API input button and we connect it to where the canvas input is. And this indicates where the post data will enter. Okay, so it has to match to the data tensor, no? Then we do the same with the output button. So for example, we connect the output to the linear regression. And now the deploy is being prepared, the API. Here we can see an example of the JSON that we would send by request. And below we have like a mini app where we can perform tests before the deploy, right? So here we can test some rows and let's see if it works and all that before the deploy. So if we hit next, now we have to write like a commit message. What it's going to do is it will save a deployed version with this commit message, and we will be able to continue editing the canvas and improving it with the next version, which we call it draft, the draft version. So write REST API test, and we click commit and deploy. So now we have to wait a little bit. Okay. And now we have the access token and the URL of the API, which is the data that we would copy to access to the canvas from the outside. So for instance, we will use a request.post with this link and this security token. Now this pop-up warns us that if we have copied all the information, and so if we want to continue. So now this version is the draft version, and the other one has already been saved with the commit message, and it's deployed on a server, and it's ready to respond. To finish, we're going to see how to load the button to PurpleDye in broad strokes. We are not going to stop long because we will explain that in more detail in our video. So we go back to the dashboard, and in the My Buttons tab, we see the buttons that I have uploaded. I have recently uploaded a linear regressor. Here we would paste the link of our GitHub repository. For example, if we open GitHub, this is the one that we are using to copy-paste the link. Then we will start the action, which now I will not do, so as not to waste time, but I will explain the process of uploading the button. Here we can see how the process started in more detail, when it has finished, which buttons it has detected, in which folders, which modules, the repository, and the status of the action. The different updates. So to understand how the process works, we insert the link here, and then GitHub itself, through the PurpleDye bot on GitHub, will ask us for the access to the repository to create a branch and execute an action. Here we can see what happens. We're in the main branch. Here we have the linear regressor. Specifically, this is the code, and this is how we import the PurpleDye library. Yeah, here it is. It's classes that we'll have to integrate with the button. So that's why I was explaining before how you integrate the insights with the PurpleDye library. To see how we can do that, we go to the partial dependence plots. We make the plot and we save it in the report as PNG. This is the integration process with PurpleDye. In this case, the linear regression inherits from abstract node, which is a class from the PurpleDye library. And it is not that complex to integrate, as you can see. Okay, so we go to the actions. Here we can see the different actions that have been executed by the bot. They are always executed in the same branch, which is a branch that the bot creates. And here we can see what's going on with the integration test that the bot is executing to integrate the button to the marketplace. When you have completed this GitHub action, this green tick would appear, and then if you go to My Buttons, you will see the button available to use. This is to give the platform much more versatility, this feature that you can upload from GitHub. And I want to link that with the concept of rapid prototyping. This means that you can start a canvas with a very simple model and a simple feature extractor, just to validate your data and the predictive power of your features, leave a first version deployed, and from there you start complicating the solution. Once you get the point that you would be interested in making a custom model, that's when you start programming, and then you integrate it, upload it to GitHub, you drag and drop the button, do the setup, and verify that everything is okay, and you can deploy it, leave it finished. So I hope you like the overview of the platform, and thank you very much for watching this video.